Okay, we're back, and gonna kind of prove the point that the memory managers, the middleware, and whatnot are complicated. Messed around with this a little bit, and again, I have an understanding of how this stuff works, and just to you're always gonna wind up troubleshooting a little bit. It's just because it's complicated stuff. So what we're gonna do is we're gonna change over to the other process. Instead of remember that there were two Pythons, and we were linked to the first Python w.exe process. We're gonna go down here and attach cheat engine to the second one. What's really going on here? I don't know. In an absolute sense, I mean, we could speculate about that the each even though the processes are named the same, obviously they have a unique hex identifier or whatever. We could speculate on what the purpose of the different processes is. If I had to guess, just off the top of my head, in case it's something you're interested or you want to read about, if I had to guess, I'd say maybe this first process is more of like an internal state for the Python interpreter and things like that. It's probably got chunks of the memory manager and different some runtime elements and things like that. And we have this process down here. It's holding values for variables and all different kinds of stuff like that. And you can read about the Python interpreter and how interpreters work on a basic level and whatnot. But for our purposes here, we're just we were messing around with Cheat Engine when it was attached to the first one. We weren't able to see the changes that we were making down here reflecting up here, and we sort of got into this area where the addresses were sort of becoming stale after 5 seconds or whatever it was. And again, there's a whole slew of technical reasons, but for our purposes, just basic trial and error. We screw around with it. First process not working. Are we completely screwed? And what do we give up and punch a hole in the wall? No. We're just gonna go back to the ground level and think about it. Be like, all right, well, we have the second process, so let's attach it to that. We'll mess around. So let's do we have a clear function or clear? No, nothing. All right. We're just going to hit enter a bunch of times. I bet we can come up here probably. Go to edit, file maybe, shell, options, Windows, zoom height. All right. Well, I'm sure there's a way to do it. I know there's a function, but or something like that. I really don't want to get into functions or anything like that. Not at this point anyway. So repeating the same process, we're going to make up a variable. We'll make up a new variable. What name we're going to call it? We'll start using humorous names again. Well, I mean, I don't know if they're humorous or not, but the name of my dog is Einstein. So we will set the variable Einstein to the value 1, 2, 3, 4, 5. Why are we using values like 1, 2, 3, 4, 5? Well, we're doing that because the bit patterns of 1, 2, 3, 4, 5 is there's a fair amount of randomness or entropy if you want to talk about that associated with that as a bit pattern. And it's big enough that you're going to be throwing in 16, 32 bits. That's going to be 16, I want to say. So that when you're doing the scan for Cheat Engine and we're trying to set up a contrived example like this, we're making the bit pattern something that's random enough that there's not going to be a whole lot of values in in this process that's going to have that bit pattern. That's going to make our initial search. We talked about this in one of the sort of the environment videos. Um, we talked about it, and we understand that we want to set up an environment that's conducive as much as possible to us controlling the values so that we can find them. Because again, we're going from value to location as opposed to what you do in a programming language, which is jump over to the right here instead of what we're doing with Cheat Engine is we're going backwards, jumping left. So we make a variable, we give it 1, 2, 3, 4, 5. We come over to Cheat Engine. Not gonna worry about data types or anything like that. We're gonna do a first scan, get a couple values. Let's change this, see what happens. We're going to change Einstein to 54321. Is it reflected over here in any of these things? It does not seem to be. There we go. It is changing over here. It's nothing that we want. So something's still going on here, and I'll talk about that. I just did that on purpose, so we can't directly just make a variable, give it a value, assign new values and stuff. There is some amount of black magic going on under the hood here, as we sort of briefly alluded to. But let's try and prove our basic point. So we have a variable. This variable has memory location. It's 54321. Let's not reassign or do anything to it. Let's just ask Python what it thinks the value of this variable is. Links to this memory location. It's going to put that, get the bit pattern out, interpret it. So now we will do this. We will change this to something. Change it to 1, 2, 3, 4, 5. Hit enter. We will come back to Python. Again, we're not reassigning to the variable or anything like that. We're just simply asking Python, what do you think the value of that variable is? You can see right there, 1, 2, 3, 4, 5. The changes that we have found the address, the changes that we are making in Cheat Engine are being reflected in here. And we'll get as soon as I'm done, as soon as we're done talking about this, we'll jump back up and see why when we're doing reassignment to the variable, why we couldn't just do that and then stuff values with via Cheat Engine into it and see those reflected. But let's just take this a couple steps further. Let's set this value to 0. We'll go ask Python, what is the value of Einstein? The value is 0. What is the value of Einstein now? We'll set it to some ridiculous number. It's going to wrap around or roll. Yeah, we'll just say wrap around, roll over, whatever you want to say. Or for our purposes, that's just a generic word. It's going to wrap around according to Cheat Engine. Let's see if Python. Come on. See if Python agrees. It does. Now, why does it agree? Well, it agrees because while Python may not care about, it's a dynamic language and whatnot, and it's, does not really concern itself with data types on the surface of it, as it may be. We can, when we're putting values into a variable, we're telling Cheat Engine what what the type of the value that we want it to put in the variable. So when we double click here and then Cheat Engine says, hey, what's the value we want, or what value do you want to change this to, and we hit enter, Cheat Engine has to interpret the bit pattern of this value in some way. How does it know what to do? Well, it's because we're telling it right here, this is how we want you to interpret it. And then it hasn't even put the bit pattern of whatever we enter in this box, hasn't even put it into the memory location yet, because it has to sort of break it down and interpret it in a way so that it knows how to stuff it in memory so that the application doesn't completely freak out. And start returning results like that, things, and whatnot. So the way that it does it is by applying sort of the filter of what type we're saying, and then, Cheat Engine says, all right, I will take this value, convert it into this data type, or the representation of this data type, and then I'll stuff that bit pattern in this address. Again, we've talked about this, but let's set this back to 0. Asking Python to reevaluate or go back in this memory location and get the value and return whatever's in there. Return 0. That's great. So what were we doing? What were we seeing earlier when we started talking about, we did Einstein equals, we'll just do 100. When we did this last time, the value here in this, we'll get rid of it. We'll delete it from down here because it's going to be useless in just a second. The value in this address was not changing, or if it was, it quickly became a stale address in the sense that, we started pushing values into it via Cheat Engine, and it was not being reflected in Python. What's going on there? Well, you can see it's not being changed here. And just to prove the point, we will ask the interpreter, Einstein, what's the value of this variable now? It's 5,000. Is it really 5,000? That's just a bit pattern that's being interpreted as 4 bytes. So let's change this value to something crazy. I don't know, we'll just make it 0. Like, I doubt it'll crash the application, or doubt it'll crash Python, the interpreter. Just ask it, what do you think Einstein is? The value of Einstein is still 100. So again, the process that we've attached Cheat Engine to is out of sync with what Cheat Engine thinks the address, or what it thinks the address that we want is. And so obviously we'd have to go back, refilter, and whatnot. We could go through and we could quite easily find that value based on what we're doing here. So what's really going on here? What's going on here, and this is I'm going to talk about this, but it's not necessary if you don't understand it. But us going over it right now and explaining the spurious results that we were seeing is going to illustrate just how much black magic is really going on in the memory manager. And we can just sort of go to Wikipedia before we jump into this. Type in memory manager in Wikipedia. What do we get? We get DOS memory management, expanded memory management, and then we just get a generic memory management article. We will click on the generic article here, and we get this nice article that will go into memory fragmentation, memory pool, probably paging, secondary storage, virtual memory, physical memory, things like that. Again, this is a very, very complicated topic that we have actually started. We've talked about memory management insofar as we've been dealing with variables and things like that. But we're going to, for the purpose of this series, we're going to sort of attempt to avoid it as much as possible because I don't want to get into it. We have to get into it, and we will get into it as much as we need to. But that's it. We're not going to go off and talk about it. But I mean, it's there if you want to. You could go to this article. You could read about it, and again, it's a very complicated thing when you start talking about managing memory dynamically, which most applications do nowadays. And a lot of programming languages provide that dynamic memory management black magic or black box that we're going to talk about right now. So what's going on here? Again, not required that you understand it, but we're going to explain it for just because we're going to. What's going on here? We're going to go down here, make a new variable. We've already used my dog Einstein. We will I don't know, stuff. We'll set this to 1, 2, 3, 4, 5. We'll do a first. Oops, we got to fill something in. 1, 2, 3, 4, 5. First scan. Get a couple values back. We know that we can start messing around and ask Cheat Engine to evaluate what's in there. Or I'm sorry, ask Python to do it. Come down here, change this value. We should have probably cleared this out a little bit before. Disregard that. Do that. We can change this value, and we can see if it's reflected in Python or not. As a matter of fact, it is. So we know that this address is the absolute, or not the absolute, but this address is the memory of the variable stuff as far as Python is concerned. Now, if we reassign something to stuff, we just say stuff does no longer equal 1, 2, 3, 4, 5. It is now equal to 5. It still has this value 5. Same memory address. Let's change this. Let's go back. Let's ask Python stuff. The value has not changed. Why? Because even though it's the same variable name, what this memory manager is doing behind the scenes is it's when we reassign a value to this variable, as far as Python is concerned, before it reassigns a value to this variable, it's going to, through a series of reference counting and things like that, it's going to essentially decide that this variable no longer exists, so it's essentially going to destroy it. As you know, is sort of a term that we're going to use. It's going to destroy that variable, and then it's going to make a new variable that just happens to have the same name. So again, this is all transparent to the end user. And so it's going to make a new variable that happens to have the same name, and it's going to stuff that value 5 into that variable, and then we can do whatever we want. And again, we'll illustrate this just one more time. We will set the value of stuff to 1, 2, 3, 4, 5. We'll search for 1, 2, 3, 4, 5. Let's get rid of this down here. We will get 3 values. We'll go with the first one. We will change it in Cheat Engine. Is that change reflected in Python? As a matter of fact, it is. We'll assign a new value, same variable, but we will assign a new value to the variable name stuff. Is that change reflected in Cheat Engine? It is not. Just to be absolutely sure it's not, we'll change the value again of the memory address in Cheat Engine, go back into Python, ask Python. The value is 2, as we set it in Python, not as we set it in Cheat Engine. What just happened? It destroyed the memory, it destroyed the stuff variable before that existed before. We are reassigning to a new variable that happens to have the same name, but the memory manager is allocating or assigning this variable to a new memory location, and so it is now invalid over here. And that last part, I wanted to explain it just so we can see just how complicated some of the stuff that goes on in the memory management is. And this will create it's possible that this could create all sorts of problems when you're using Cheat Engine and trying to deal with programs and find values and things like that. But for our purposes, we've demonstrated that we can make a variable, we can find that variable in Cheat Engine, we can change the value of the variable in Cheat Engine without executing an assignment statement or anything like that in Python. We come back into Python, we tell it to recheck the value of the variable, and it will reflect what we did over here. So we are dynamically finding and changing values with as much control as we need, because this is an actual programming language. Can't really prove the point any more than that.